In today's class, we shall see how to graph the inverse of a function. We have to familiarize with the three words: graph, function, and inverse of a function. First, let us see what is the meaning of a function. Consider two sets, set x and set y. Both are non-empty. X will have some elements, y also will have some elements. Now we define a rule F which assigns every element of x with a unique element of y. A rule which assigns every element of x with a unique element of y. This kind of rule is called a function from the set x to the set y. The set x is called the domain and the set y is called the codomain of the function. As an example, let x be the set 1, 2, 3, 4, 5 and y be the set A, B, C, D, E and F. Let us assign 1 with A, 2 with B, 3 also with B, 4 with D and 5 with F. This defines a function because the required two rules are satisfied here, two conditions are satisfied here. First condition, that every element of x is having an image. So A is called the image of 1, 2 is called the image of B. B is the image of 2 and B is the image of 3 also. D is the image of 4 and F is the image of 5. The second requirement or the condition is that one element of x should be assigned only with one element. You cannot have more than one image. Here 1 has got only one image, 2 got only one image, 3 also got only one image, like that. So these are the two requirements. Every element of x is assigned with a unique element of y. Since the conditions are satisfied, this defines a function f from x to y. These assignments can be written as ordered pairs. For example, ordered pair 1a. This is called an ordered pair because it is a pair ordered in a particular way. The first element of this pair is coming from x and the second element is coming from the set y. Similarly, 2b, 3b, 4d and 5f. These are the ordered pairs corresponding to this particular assignment. Inverse of a function. if f is a function which is defined from x to y, then we can find f inverse as defined from y to x. Here we have 1 is assigned to A. In f inverse, it will happen the reverse order. A will be assigned back to 1. Similarly, all. For example, again, 5 is assigned with f. In the reverse order, it will be assigned with 5. F will be assigned with 5. So, this is called the f inverse. Now, the ordered pairs of this f inverse can be written like this. Ordered pair A1, ordered pair B2, ordered pair B3, ordered pair B4, and ordered pair F5. F inverse formed with these ordered pairs is actually not a function. It is only a relation. It is not a function because it violates the conditions. The first condition was that every element is assigned with a unique element. Here you see A, B, D, F. Only 4 elements have images. Other C and E does not have images. So the first condition itself is violated, so this cannot be a function. Here in this case, the second case is also violated because the same element B is assigned with 2 different elements, 2 and 3. That is the violation of the second rule. So this f inverse cannot be a function in this case. So this can be made into a reversible or inversible function by making some changes in this. So instead of sending 2 to B and 3 to B, let us send 3 to somebody else. Say, send 3 to C. Four to D and 5 to F. So that one condition is satisfied. That is each element when you take the reverse, each element, this A is having only one image, B is having only one image, C is having only one image, D is having only one image, F is also having only one image. But the second thing that this E is not having any image when you look back. So we have to remove that E from the. Now when you define function backwards, every element A, B, C, D and F, all of them has inverse image and each element is having only one image, unique. So the reverse or inverse also will be a function. Now such kind of functions, this kind of function which is one-to-one and onto, this kind of functions are called one-to-one and onto functions or bijections. Real functions. Suppose the domain and the codomain both are subsets of real numbers. In that case, the function defined from R to R, or the subset of R to subset of R is called a real function. Here, suppose you take x is a real number and x is sent to y is also a real number. Usually, we write y is equal to f of x. Y is a function of x. For example, suppose you define y is equal to 2x. So let example, y is equal to 2x. Here we can consider just like a machine. Suppose you input x, output will be y. Now how this y is calculated? It is calculated with a function rule f of x is equal to 2x. That means if you put 1, according to this rule, 1 multiplied by 2 you get 2 and the output will be 2. Suppose you put a real number, say pi. So according to this rule, 2 multiplied by pi you will get 2 pi. So 2 pi will be the output. Like this manner you can put any real number belonging to this set. This can be whole set of real numbers or can be subset of real numbers, no problem. All the elements here can be substituted here and accordingly you get a real number as the output. Let us consider an example of a real function. Say y is equal to 2x plus 3. Now there is a method for finding the inverse of this function algebraically. Let us see that. There are 3 steps for that. First step is to interchange x and y. That means you write x is equal to 2y plus 3. Second step is to solve for y. That means from here you have 2y is equal to x minus 3. So y is equal to x minus 3 by 2. In step 3, this y represents a function. So you can write any name for that. Suppose you write it is g of x. G of x is equal to x minus 3 by 2. Actually this is f of x is equal to 2x plus 3. And here you get g of x is equal to x minus 3 by 2. So actually g of x is inverse of f of x. So instead of g of x, we can write f inverse x also. Now the property of f and f inverse is that f inverse of f of x is equal to f of f inverse x is equal to I of x is equal to x. Now let us see the meaning of it with the help of the example. We have f of x is equal to 2x plus 3 and f inverse of x we calculated as x minus 3 by 2. Now what is f inverse of f of x? This is equal to f inverse of f of x means 2x plus 2. Now the rule of f inverse is that when this x is input here, you have to calculate the value of the image by putting this x here. That means x minus 3 by 2. Similar manner, f inverse of 2x plus 3 can be calculated by replacing this x with 2x plus 3. So this is equal to 2x plus 3. Means instead of x you have to write 2x plus 3 minus 3 the whole divided by 2. That's equal to this plus 3 and minus 3 cancels and you get a 2x by 2. 2 and 2 get cancels and you get x. So f inverse of f of x is equal to x. Now let us see what is f inverse of x. This is equal to f of x minus 3 by 2. That's equal to, according to the rule of f of x, it is 2x plus 3. That is, whatever is coming here, we multiply by 2 and add with 3. So, here instead of x, we have x minus 3 by 2. So, you multiply it with x minus 3 by 2 plus 3. This 2 and 2 cancels and you get x minus 3 plus 3. Minus 3 and plus 3 cancels and you get x. Again, f inverse of x is equal to x. We call it I of x because this I is a function which is known as identity function. And identity function means it does not do anything to the input value. So if you put 1 here, output will be 1. If you put input as 2, output will be 2. Like that, whatever value you give, output will be the same. That kind of function is called the identity function. So actually f inverse, or composite of f inverse and f of f inverse gives the identity function. That's a very important property of these functions. Now let us see the function y is equal to 2x plus 3. We will make the ordered pairs x and y corresponding to this function. Let us put x is equal to minus 3. Then 2 into minus 3, minus 6. Minus 6 plus 3, get minus 2. Put minus 2, minus 4 plus 3, minus 1. Put minus 1, minus 2 plus 3, 1. Put 0, 0 plus 3, 3. Put 1, 2 plus 3, 5. Put 2, 4 plus 3, 7. Like that we can find the ordered pairs. Now these ordered pairs we can plot on a graph. We draw the graph on two mutually perpendicular straight lines known as x-axis and y-axis. So I have plotted all the points minus 3, minus 3, minus 2, minus 1, like that. All these points I have plotted, and I have joined all these plotted points to get the graph of the function y is equal to x plus 3. Now, to draw the graph of the inverse of this function, we need ordered pairs of f inverse, and that we get by interchanging x and y. Just interchanging these x and y, you will get the ordered pairs of the inverse, and plotting those points and joining the line, you will get the inverse of this graph. So the ordered pairs of the inverse are obtained like this: minus 3, minus 3, minus 1, minus 2, 1, minus 1, 3, 0, 5, 1, 7, 2. And these points are plotted and the line is joined. Now this will be the graph of the inverse of this function. One important thing that you have to understand is that there is a line called the graph of the function y is equal to x, and that line is passing through the origin, making equal angles with the coordinate axis. These two lines, or these two graphs of f and its inverse, will be mirror images of each other with respect to that line. So y is equal to x means both x and y will be equal. So this is the line y is equal to x. This is the graph of f and this is the graph of f inverse. These two graphs of f and f inverse are mirror images of each other with respect to this line y is equal to x. Let us consider another example. Y is equal to x square. Disordered pairs are x, y, minus 3, 9, minus 2, 4, minus 1, 1, 0, 0, 1, 1, 2, 4, 3, 9. These are the ordered pairs. It's already plotted. Minus 3, 9, minus 2, 4, like that. All the points are plotted and we are joining it with a smooth curve. And this curve is known as the parabola. Now, in order to find the inverse of this, as usual, we reverse the order of x and y. One problem with this is that this will not define a function because same 9 is getting two images, minus 3 and 3. Similarly, 4 is getting minus 2 and 2, like that. So this will not define a function. There is a test which is known as horizontal line test. This test is used to find if the function is invertible. Means the f inverse is also a function. That is meaning of telling f is invertible. This f is not invertible because as we have seen, f inverse is not a function. So this horizontal test tells us that if you draw a horizontal line, it should not meet the curve in more than one point. Here this curve is meeting this horizontal line in more than one point. So the inverse will not be a function. So we consider only this right part. Domain, we restrict the domain to 0 to the right, so positive x-axis. In that case, this will be the original function. And it will pass the horizontal test because this line, this horizontal line will meet this only at one point. So this is invertible. Only this part, if you are considering, that is invertible, and its inverse we can show. Again, if you consider only this left part, that is domain is restricted to the negative part of the x-axis, this line or this curve will be invertible because it will pass the horizontal line test. This horizontal line is meeting the curve at one point, so it will pass the horizontal line test, and its inverse we can find out. By plotting 9 minus 3, 4 minus 2, 1 minus 1, 0, 0, and joining the points using the smooth curve, we get this, and it is the inverse of this part of the curve. Similarly, plotting 0, 0, 1, 1, 4, 2, 9, 3, we get this curve, and it is the inverse of this part of the curve. Now, as before, if you draw the line y is equal to x, these inverses will be mirror images of each other about that line. So it is very clear that this curve and this curve are mirror images of each other about this line. Similarly, these two curves are mirror images of each other about this line. Now, let us summarize what we have learned today. We wanted to graph the inverse of a function. This can be done in 3 steps. In step 1, we find sum of the ordered pairs corresponding to f. We plot them and graph. By joining these plotted points, we graph f. In step 2, we find the ordered pairs of f inverse, which is obtained by reversing the order of the elements of the ordered pairs of f. Plot them, join them to get the graph of f inverse. In step 3, we draw the line y is inverse and examine that f and f inverse are images of each other with respect to this line y is inverse.